All right, Math 8 students, here we go. This is our second flipped classroom lesson, lesson 3.1, representing proportional relationships. We're going to look at just a couple key vocabulary terms here that will be applied later in the lesson, and then we'll get rolling into the lesson itself. So the first term we're looking at is proportional relationships. A proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other is constant. Constant meaning it does not change. So this is a relationship between two quantities, two values, in which one to the other will not change. Like 12 inches to 1 foot. That is not going to change. That is a constant ratio. The second thing that we're looking at is a constant of proportionality. And that is a constant ratio of two variables related proportionally. Proportionally, again, is saying that you can set something equal to something else, that they are equivalent, that you can make equivalent fractions out of them. Again, that is an example of vocabulary review from the previous lesson. So we can look at 12 inches to 1 foot. That is proportionally related to 24 inches and 2 feet, and also 36 inches and 3 feet. So that is a ratio here that is constant, and these three are related proportionally, these three examples here. Alright, so the key concept that we're using in this lesson is that a proportional relationship can be described by the equation y equals kx, where k is the number called the constant of proportionality. So this can also be written as k equals y over x to solve for that constant. So if I was looking at my inches and feet, I could say, oh, I got 36 inches and 3 feet. I've got 24 inches and 2 feet. I've got 12 inches and 1 foot. My value, my constant here, would be the simplest version of this, right? So if all of these, I would have 36 over 3. That should equal 12 over 1. And 24 inches to 2 feet, that should also equal 12 inches over 1. So my simplest form here, my 12 over 1, that is my constant of proportionality. So this would be my k, constant of proportionality. Let's go ahead now and move into a couple examples of this, representing proportional relationships with tables and equations. And we can represent proportional relationships with tables and equations and graphs. We're going to get to graphs in just a little bit. So looking at this question here, Megan earns $12 an hour at her part-time job. She shows that relationship between the amount she has earned and the number of hours that she has worked, as it is a proportional relationship. Show that the relationship between the amount that she has earned and the number of hours she has worked is a proportional relationship. Then write the equation for the relationship. Again, that equation is going to be y equals kx, and we can use that the form k equals y over x to solve, but that's going to come in a little bit later. So if she earns $12 an hour, we're going to go ahead and say the amount she earned in 1 hour would be 12. So $12 in 1 hour. And we're just going to fill this in 1 hour at a time. So this would be 2 hours. She would earn $24. In 3 hours, she would earn 36. And you can continue this on. I'm going to go ahead and just jump to say 6 hours. She would earn 72. And in 8 hours, she would earn $96. So I've completed this table based on the information that she earns $12 per hour, and then just filled in a couple of variables from there. So complete the table using a ratio of dollars earned to hours worked. Again, we're going to be essentially finding the equivalent fractions here. This will give you the constant of proportionality. So this is my base value here, right? She earns $12 in 1 hour. So if this is a constant ratio, all of these values should simplify down to the same ratio. They should all simplify down to $12 an hour. So I'm going to go ahead and look at 24 in 2 hours. If that simplifies down to $12 in 1 hour, so that is constant. Let's look at 36 in 3. Again, that simplifies down to $12 in 1 hour. And again, $72 in 6 hours, that simplifies down to $12 per hour for 6 hours. And my last one here, $96 in 8 hours. Again, that would simplify down to that rate of $12 per 1 hour. For 8 hours, we'll give you $96. So do I have the same constant of proportionality here? Do all of these simplify down to the same value? Are all of these equivalent fractions? If so, then they are proportional, and our constant of proportionality is the one that they simplify down to. So let's go ahead and write that equation. Let's go. So I'm going to identify the variables, which would be my x and y. My x, which is my independent variable, is going to be my hours worked, right? Because the amount of money that I make does not dictate the amount of hours I work. Instead, my dependent variable, which is my money earned, or dollars earned, depends on the hours I work. So this is my dependent variable, my y value, the dollars earned. My independent value is hours worked, because time will pass whether I'm working or not, but if I want to earn money, that does depend on how many hours I work. So my constant I can find with the equation k equals y over x. So hours worked would be my x, and y, my dependent here, is the dollars earned. And we figured our constant of proportionality, our y over x, would be 12 over 1, $12 per hour. So this means that my equation y equals k times x, meaning dollars earned is equal to the dollars per hour times my hours, would be y equals $12 per 1 hour times x, or y equals 12x, because anything over 1 can be simplified down to just that value itself. 12 over 1 can be just 12. And remember, when we put numbers next to each other like this, that indicates multiplication. So when you get practiced at these, when you do a lot of these, you'll be able to just, take a look at the equation and be like, oh, she earns $12 an hour. If they give you a rate of $12 an hour, you might, okay, well, that's proportional. I know how to write this equation. But they may not always be constant. So what I want you to do now is I want you to try this one on your own. So go ahead and pause the video, try working this one out. It wants you to write the equation, and then once you've solved it, go ahead, press play, and see if you've got the answer correct. Okay, so here's how you would solve this your turn problem. 15 bicycles are produced each hour at the Speedy Bike Works. So what is our rate here? We got 15 bikes each hour, so 15 bikes per hour. Show that the relationship is between the number of bikes produced and the number of hours is a proportional relationship. Then write the equation for the relationship. So I want to know that this is proportional. I'm going to say, well, if I produce 15 bikes in 1 hour, that should equal 30 bikes in 2 hours, 45 bikes in 3 hours, and so on and so forth. This is pretty simple. This is pretty straightforward. So yes, all of these, they're multiples of each other, so they would simplify down to the same value here of 15 bikes per hour, which means that my constant is going to be my y value over my x value, my bikes over my hours, and that would be 15 over 1, because my constant rate that I am producing bikes, my constant ratio is 15 bikes every 1 hour. So when I go to put this in that equation, that's going to be y equals k times x, my dependent variable, multiplied by my constant of proportionality, my dependent variable will equal the constant of proportionality multiplied by the independent variable. So in this case, number of bikes per hour multiplied by hours will give us our number of bikes produced total. So that will be y equals 15 bikes per hour times x, or you can write that as y equals 15x. Pretty straightforward. So let's go ahead and take a look at how we would use graphs to solve for the constant of proportionality. So representing proportional relationships with tables and equations, and, in this case, graphs. I like graphs because they're very visual. It's very easy to see if it's a constant of proportionality, because the graph of a proportional relationship is always a straight line that goes to the origin. This is really important to remember. This is a key concept here that we want to remember. The graph of a proportional relationship is always a straight line, and it has to go through the origin. So the origin is here, it's that 0, 0 value, right? So just by looking at this graph, we can tell that this is a constant and proportional relationship of whatever it is that we're looking at. We haven't even looked at those values yet. So let's go ahead and do that. So the graph shows the relationship between the weight of an object on the moon and its weight on Earth. Write an equation for this relationship. So that's going to be that y equals kx relationship. So looking at the graph, we have our y-axis here. This will always be your y-axis, this vertical one. And our x-axis here, horizontal, will always be the x-axis. So our values are already, our variables are already identified for us. Our dependent variable and independent variable. Oh, I did that backwards. Our dependent variable y and our independent variable x. So we've got the moon weight, and what it wants us to do is use the points on the graph to make the table. So we've got the weight something might be on Earth and versus the weight it would be on the moon. So we've got these 1, 2, 3, 4 points here. We're going to use these 4 points to go ahead and fill in our table. This first point here, x, is 6. So weight on Earth, if it's 6 pounds on Earth, it's going to be 1 pound on the moon. Second point here, if it's 12 pounds on Earth, it's going to be 2 pounds on the moon. Third point, if it is 18 pounds on Earth, it is going to be 3 pounds on the moon. And our final point here, we jump all the way up to 30. If it's 30 pounds on Earth, it is going to be 5 pounds on the moon. So 30 pounds on Earth, 5 pounds on the moon. So you could take a look at that and be like, oh, well, whatever it weighs on Earth, it's going to be 1/6 of that on the moon. That's interesting. Figure out what you'd weigh on the moon if you'd like. So the next thing that we're doing is going to find the constant of proportionality. That is our k value, and we know that k equals y over x. We already identified our x and y based on our graph here. The Earth is our x value, and the moon is our y value. These are opposite of how we want to write them over here, though. So we've got the moon weight, and it's already written here, where k equals y over x. So moon weight is y, Earth weight is x, and we know that 1 pound on the moon will be 6 pounds on Earth. And we're going to check and make sure this relationship is proportional just by plugging these in. And this is a little bit redundant because we know that we can look at that graph, and if it makes a straight line and it goes to the origin, it is a proportional relationship. But we're not always going to have a graph, and we're not always going to have numbers that we can easily reduce to see if we have a constant relationship. So this is practice for those skills for when we don't have nice, simple, equivalent ratios. So we can see that all of these ratios, all of these relationships are equivalent, and they do all reduce down to that 1/6 value. 1 pound on the moon is 6 pounds on Earth. So our constant of proportionality, this is a constant relationship, and our constant of proportionality is that 1/6. So we're going to write that equation now. y equals k times x. And we're letting x represent our earth weight. And that was given to us, right? That was given to us on the graph here. And we're letting y represent our moon weight. And k is going to be y over x. And that is going to be y is 1 pound to every 6 earth pounds. So k equals y over x, which equals 1 over 6. So our equation, y equals k times x, we plug in that value of k into this equation, and we got y equals 1 over 6 times x. In this case, what these variables mean is the moon weight will be 1/6 times the earth weight, or 1/6 of the earth weight will give you the moon weight. So now you're going to go ahead and try one on your own here in the Your Turn. And what I want you to do is go ahead and pause the video, work through this, solve it, and then press play and make sure you did it correctly. Okay, so let's take a look at the Your Turn. Here it says the graph shows a relationship between the amount of time that a backpacker hikes and the distance traveled. Alright, super cool. We got a graph here. I like graphs. They're nice and visual. And we know that the graph of a constant, the graph of a proportional relationship is going to be a straight line through the origin. So we already know that this represents a proportional relationship because it's a straight line through the origin. But we're going to go ahead and practice and answer these questions in Your Turn. So what does the point 5, 6 represent? This is x and y, because that is how we write points on a coordinate plane. So we've got x is 5, which would be time, so 5 hours, and y is distance in miles, which is the distance traveled. So in 5 hours, you have traveled, or the hiker has traveled, 6 miles. Now, you guys want to make sure that you recognize the units that they're measuring on each of these axes, because this is not every one. This is every 2.5 hours here. If you break it down, this would be 2.5 hours. This would be 5, 7.5 hours, 10. So make sure that you're identifying what those values are, and that they are not always going to be the same on each axis, because here we go up by 2 miles. So what does 5, 6 represent, the point 5, 6? Well, 5 hours hiked 6 miles. So we're going to go ahead and write that down, that in 5 hours hiked 6 miles. You could also write in 6 miles they hiked, or it took them 5 hours to hike 6 miles, or 6 miles were hiked in 5 hours, as long as you got the essential here that the rate was 6 miles in 5 hours. So what would the equation for this relationship be? Well, let's go ahead and take a look. We know that it's a constant, and we know that it's a constant rate, and we know it's a proportional relationship because it goes through the origin and is a straight line. So, but if we didn't know that, if we just had these values here, we could go ahead and take these values, and this is a little bit of the long answer here. So you can fast forward through this if you'd like, if you don't really need this explanation, but it does give us another way to look at this. We have 5, 6 as this point. We've got 10 and 12 at this point. We've got 15, 18 at this point. So again, this would be at 10 hours, they hiked 12 miles. At 15 hours, they hiked 18 miles. And we want to make sure that this is a proportional relationship. So all of these should simplify down to that base ratio of 6 to 5, right? So 18 over 15 simplifies to, or is equivalent to, 6 over 5. And 12 over 10, 12 miles in 10 hours, also simplifies down to 6 over 5. So this is another way that we can see that that is a constant and proportional relationship. So that means that k equals y over x. And in this case, that simplest one here is k equals 6 over 5. 6 is our y value. 5 is our x value. We know that based on our graph. And so then we're going to go ahead and plug that in to our equation, y equals k times x. So y equals 6 over 5x. So this is our base value here, and that's going to tell us that whatever time we hike, whatever amount of hours that we hike, we multiply it by that constant of proportionality, and that will give us the distance that we hike per mile in miles. Okay, so that's it. You'll have a little bit of a check. Make sure you did the notes and understood the concept when you come into class first thing tomorrow. If you have questions, please make sure you're writing those down as you go. Please make sure that you ask when we come to class, because we're just going to be working on this lesson when you come in. I will see you all tomorrow.